ELA Core is a 5G core designed for private networks. It sips on resources and it works on both AMD and ARM architectures. It is so efficient, it even runs on a Raspberry Pi. Hi, my name is Guillaume and I run ELA Networks. In this video, I will show you how to install ELA Core on a Raspberry Pi, how to integrate it with a 5G radio, create a subscriber, and connect a 5G phone to our private network. Now let me connect this Pi. So in terms of physical connectivity, I connected the Pi to power, as well as to two Ethernet cable, one via the Pi's Ethernet NIC, and one via a USB adapter. Okay, now let's SSH into the Raspberry Pi. So I'll share my terminal. There we go. All right, so we're in. Now let me prove you that we're actually using a Raspberry Pi. We see that we're using a Raspberry Pi 5 here, model B, and it's the model with 8 gigs of RAM. Let me show you that we're using Ubuntu 24.04 as our base operating system. Okay. And in terms of network interfaces, like I mentioned, we're connected to two networks, one with ETH0 and the other one with this ENX that's connected to our USB adapter. Let's go ahead and install ELA Core. And since ELA Core is a strictly confined snap, we also need to connect it to a few interfaces. So network control, process control, system observe, and firewall control. Now I will edit the configuration file so that it matches with our system's network interfaces. Okay, so I'll edit N2. So that uses ETH0. I'll edit N3 so it uses our ENX interface. I'll paste it since the name is quite long. And I'll edit N6 to use ETH0 as well. I will also edit the XDP attach mode from native to generic, and we'll come back to that in a few minutes. Okay, so now let's start ELA Core. Okay, it is started. So now I'll share my browser and we'll go ahead and connect to our web interface. Okay, so let me go to 192.168.40.40 at port 5002. So 40.40 is my Raspberry Pi's address and 5002 is the port that is used for ELA Core's UI. Okay. There we go. So we're greeted with the initialization page. So we need to create a first user with the email and password. Okay, there we go. So in operator, I'll change the operator ID to 99901. And I'll also change the home network interface information because I already have a SIM card that I already burned, and it is burned with this information that I'm pasting here. There we go. In radios, you will notice that the radio here is already connected. That is because this radio is configured with the Raspberry Pi's address as its AMF address, and it's already started as well. So we'll also need to create a subscriber. And here I will paste the values that I used to burn the SIM card. Okay, there we go. So now I will screen record on this Motorola phone, and I will insert the SIM card into it so that you can see exactly what I'm seeing. So let me start a screen recording. Okay, so we're screen recording now. And let me insert the SIM card into the phone. If we look at the top right of the phone, it will go from having no connectivity to having 5G connectivity. There we go. So at the top right here, we can see that we have 5G connectivity. So now I'll press on settings, network and internet, SIM and mobile networks, and you can see LI is over here. And here you can see that we're connected to network 99901 and that we're using 5G. We can also open Chrome and a new tab here, and we can search for LAN networks, for example. And you can see that we're connected to our private 5G network. We're able to reach out the internet and go to this website. Okay, now let me press stop recording. There we go. Okay, so now let's look at how much resources our Raspberry Pi is using to be able to run a private 5G network. So let me go back to the terminal and let's run btop. So here, if I click on core, you can see that we're consuming around 35 megabytes of memory, which is very few. This is an 8 gig Raspberry Pi model. We could have gone with a 1 gig model, and we should be just fine as well. We're using very few CPU as well. It will be hovering between 0 and 2%. Note that we're only using one subscriber here. So as you grow your subscriber list, you will be consuming more resources, and that's to be expected. Another thing to note is that earlier we switched the XDP mode from generic to from native to generic. That is because the NIC driver for the USB adapter does not support XDP. Generic here means that ELA-Core in this configuration is not leveraging kernel level packet processing. It's not going as fast as it could. So the other driver, however, for the physical NIC does support XDP. So instead of using two physical network interfaces, we could use just one, but that means we would need to use VLAN or something similar to segregate our networks differently. So that's possible, but it would complicate configuration a little bit. Okay. So in a couple of minutes, we were able to install ELA-Core on a Raspberry Pi. We're able to integrate it with our 5G radio, create a subscriber, connect a phone, and we could see that we're barely using the Pi's resources. So if you want to know more about ELA-Core, go to elanetworks.com. Thank you very much for watching.